Hi everyone. Today I want to talk to you a little bit about data on the dark web. My name is Derek Fisher. I've been in engineering, both in hardware and software, for over 20 years. I spent past 7-8 years in software security, mostly as an architect, as a leader in both the healthcare and financial sectors. I do teach an application security class at Temple University here in Philadelphia. And this year I founded the company Securely Built, with the purpose of providing security education to businesses and individuals, both non-technical and technical. If you want to look me up, I'm on LinkedIn. You can find a link there. Okay. So one of the important things when we talk about data on the dark web is the data. How do we define the data? More importantly, how do we define data that is at risk? Typically, when we talk about data, sensitive data and data that's at risk, we're talking about PII. This is personally identifiable information. So that could be anything like a full name, an address, email, social security number, passport, driver's license, and so forth. PHI, on the other hand, protected health information. It's pretty much the same stuff that PII includes, with the added information surrounding specifically healthcare. So think of things like biometrics, images such as x-rays and CAT scans, MRIs, maybe your medical record number, health beneficiaries, information like that. And then the other area that we're probably all most familiar with is financial data. So this is, the obvious ones like credit cards, bank accounts, loan fund data, that kind of information. And we're also seeing that some of the regulatory, whether they're laws or regulatory motions in some countries and states, specifically like GDPR, also designate certain data as protected. So things like race and ethnicity, political and religious and philosophical beliefs are all considered protected information under regulations like GDPR. So where is all this data being collected? Well, most common places are, in the financial sector. You look at your bank, your credit card, your employer, places of business that you purchase, items from. They're obviously collecting data on you. In the healthcare space, your hospitals, your doctor's offices, dentists, insurance companies, they're all collecting healthcare information. Things like IoT, so Internet of Things, your home, your car, your watch, your phone. Those are all collecting information on you at any given time. And then, of course, we willingly release a lot of sometimes protected information on places like social media. Maybe 10 years ago, it would have been unthinkable that you would go walk on the street and yell out to everybody what you had for lunch, but we do that regularly on social media. And then also you look at retail establishments, so stores that are collecting information through things like the rewards programs. Maybe they have certain the rewards programs or the way they track you in the store. There's a lot of stores that are using IoT, Internet of Things, in order to provide better user experience to you. They're tracking you throughout the store, keeping track of stock and keeping track of what you're looking at when you're not looking at. So the retail environment, especially coupled with IoT, is finding a lot of use cases for collecting a lot of data. But the truth is that this data is being collected everywhere. And businesses are getting better at collecting that information, making both their job easier and hopefully providing value to the client or the customer. So how is this information being collected? Well, in some cases, the service provider, the person that's, whether it's your healthcare, your bank, the retail store, they're directly asking you. You're probably signing forms or signing, some kind of quote unquote contract when you engage with them at certain levels. So they're going to be directly asking you, is it okay for us to collect data and potentially share that? Sometimes that information is location based. So, your car, your phone, your watch, your smartwatch. If all GPS is turned on, or your Bluetooth or your Wi-Fi, there's ways to determine your location, based on those telemetries. So that information is obviously being collected and used. And once this information is captured, it changes hands. So they have these data exchanges where, and we're probably most familiar with, places like Facebook and Google that do collect this information and either sell it or use it, to provide better targeted ads. And we're really seeing that, things like GDPR, the European Data Protection, and as well as the California Consumer Protection Act. We're really seeing those really understand the dangers of collecting all this information, and more importantly, trying to put guidance and frameworks around how this information should be protected, because we see that a lot of people are becoming more and more concerned about their data being out there and how it's being used. So got it. All this data is being collected. Storage is important. So what is this really being used for? And first, let's talk a bit about how the businesses are using this information. So as I mentioned before, specifically in a retail type of environment, especially with IoT, they are looking at, some stores are looking at how consumers spend their time in certain parts of the store. You may have heard about Amazon Go, which is a grocery store that allows somebody to walk in and basically walk out without ever touching a register or ever talking to a worker. It's a completely automated store, and the way they do that is by tracking you through the store, tracking the items that you're picking up, tracking the items that you're putting in your bag, and there's no barcodes or anything like that. You put stuff in your bag and you walk out. That kind of model is going to continue, in the retail environment, where there's a constant collection of data about where you're at, what you're doing, what you're looking at, what you're not looking at, to better provide a more tailored experience to you. But also from the business perspective, they're going to stock the things that are moving and not stock so much on the things that aren't being sold as frequently. So it's really about the targeted, marketing and targeted experience for the user. And some companies will argue that collecting this data provides more security. So for instance, as I mentioned before about the location based. So if I log into my bank on a regular basis, and the window of time that I'm logging into my bank is Monday through Friday, between the hours of 6 p.m. and 9 p.m. is the most likely time I'm logging in. Maybe on the weekend, on Saturday, I log in the morning, but it's pretty standard time frames when I'm checking my bank account. Now, and it's usually from the same location. It's either from my home computer, maybe it's on my cell phone. But if for some reason the bank sees a login from Singapore at 3:30 in the morning on a Monday, well, that's going to look suspicious, right? And that the bank or in this whatever the service provider is, at that case, in that case, can make a decision to try to do some step up type of authentication or authorization. So it might ask more probing questions and make sure it's really me and not somebody trying to spoof me. But the bottom line about this data collection really comes down to making money. Again, Facebook and Google, they make a lot of money off of collecting data and selling it or using it to better target their users. So what about us? What about the individuals? What we typically see is the data breaches that are constantly in the news. We see a lot of different variations of those attacks, whether they're ransomware, insider threats, people that are on the inside that have access to information that they release or they steal or they sell. A lot of mistakes as well. People just not being good stewards of the data, which sometimes can cause mistakes. So we're also seeing a lot of as far as the data that's part of those breaches or security incidents. their financial, their healthcare, their personal, and of course the big one, that you hear a lot about is passwords and usernames and passwords. Databases that get taken or stolen. You hear a lot of stories about the with usernames and passwords in those databases. And honestly, like some of these numbers and things to keep in mind is that these are the attacks that get reported. These are the incidents that get reported. There's a lot of incidents that go unreported or just not reported until sometime down the road. So how are attackers using this data? It depends on the information that they're getting, and it depends on what they're trying to do with that information. So sometimes they're just trying to make money off of it. Sometimes they may be trying to actually target a specific person. So we're going to show an example here in a minute, but where small bits of data are allow an attacker to figure out more information about the person and create a larger attack surface for an individual that they may be targeting. So there's a tool called Maltego. I'm going to show that here in a second. And it's basically a way of creating a social engineering. It's a way of collecting, gathering more information or expanding out the information that you have. So if I have a name or an email address or a physical address or like a domain name, I'm able to use this tool to be able to scour more information across the internet to figure out more, to get more information about the person or the entity that I'm trying to target here. So it's a reconnaissance tool. It's not made for specifically for attacking. It's more for just gaining more information about something or someone. And what you notice here is that I have the community edition, which is basically free to download. There is a more powerful version of this that is for purchase that a lot of sometimes companies, anybody that's in law enforcement or military or in cybersecurity that needs to get more information, for legitimate purposes, they would have the full-blown version of this. Now, this tool is available free to download. Doesn't take very long, and as you'll see here in the demo, it's very user-friendly, and you can, within a few clicks and a couple minutes of patience, you can basically get a good amount of information depending on what you're looking for. So I'm going to go ahead and show this demo here real quick. And basically, I have a video. I'm a video gamer, and I'm going to show here my alias, online alias here that I've had for a very long time. And I'm going to show here how quickly it is, or how easy and quick it is to get more information just off of that alias. Now, transform is basically, as it kind of says, it's a way of transforming one thing into something else. One of the important things you'll notice here is that based on my gaming name here, I'm able to tie that back to my real name. You also see some of the other sites that I use that name for, so Reddit, GitHub. But more importantly, again, you see here that it was able to figure out that my real name is Derek Fisher. And from here, I can kind of break it out more, and you'll see, ties back to, my Twitter account using my real name, and then to my actual person, Derek Fisher. So how can you profit off of that information? Once you gather that information, obviously, that the example that I just showed is very, it's it was a few minutes, couple quick clicks. But in the hands of a more somebody that's really trying to get more information about an entity and has the better version of the tool and has better skills, they're able to obviously dig in and get a lot more information on me or anybody else. So what are we doing with that? Not us, but what are attackers doing with that information once they have it? In some cases, they could be getting that in, building that out. to find out more information about you to open up accounts. Maybe they are able to find out, your address or, your physical address, or maybe they're able to find out, some information about you that leads them to be able to create a more targeted attack to you. Maybe they know where you work, so they can kind of spoof your employer, or they know some of your affiliations, so they're able to create a better spoof to specifically target you. So again, like, that tool itself is not, it's not an attack tool, but it certainly can provide more information for somebody if they're looking for a way to better target, a specific person or entity. So when we talk about the dark web, and we talk about data that's on the dark web, the question comes up, about what your data is actually worth, and that's a difficult question, because it really comes down to asking a similar question, like what's that car worth, your vehicle, and it depends on things like what's the make, what's the model, what's the year, what's the trim level, did you do any aftermarket, customization. So like most things in technology, what your data's worth really kind of depends. And I like asking this question when I've presented similar topics in the past. I would ask, you know, in the room, I would say, how much does a social security number go for? How much does a credit card number go for? And you get some people that uh, are really close, and you get some people that are way off. And then I asked a question about medical record. What do you think a medical record's worth? And actually, a medical record is the highest, in terms of fetching a price on the dark web, on the internet. So, things like, a credit card number might go for $100. A social security number might go for $1, maybe a little bit more. But the medical record, depending on what's in it, could go for $1,000. And it really what's behind that price? Well, it comes down to, with a credit card number. We're all familiar with this. If anybody's had their credit card number stolen, that that credit card number, and the bad guys know this too. That credit card number is only good for so long, because the minute it gets used in a way that raises flags by the credit card company, they're going to shut down the account. They're going to notify the legitimate owner of that credit card, and there's no more purchasing available. So you only have a really short period of time to use that credit card number. And if your credit card number gets stolen, you'll call your bank, and the first thing the bank's going to do is send you a new one, right? With a medical record, and again, it really depends on what's in that medical record, but you have information about yourself. So you have, PII, you have PHI, you have diagnosis information in there. You may have information related to your relatives, so your relatives' medical history. You may also have information around your insurance company, so that's where the financial aspects come into it. So depending on what's in that medical record, there's a lot of information that can be gleaned off of that and used to create things like insurance fraud, or again, better target you. Or there's actually the case of Charlie Sheen way back when he was first diagnosed with AIDS. He kept it quiet. Somebody was able to get to his medical record, find out that he had an AIDS diagnosis, and basically blackmailed him and said, if you don't give us whatever the number was, $1 million or $2 million or $10 million or something like that, then we're going to go public with your diagnosis. Well, he turned around, the next day, and actually went on the news and gave up his diagnosis anyway. But the point being that, we're not all Charlie Sheen, but there's data and information within your medical record that can be extremely sensitive, and can be extremely damaging, depending on who you are, or just you just don't want that information out. So so you can see the different kinds of use cases around that data, and why some pricing is different than others. All right, so we'll talk a little bit about the Tor network here. So So from a high level, the Tor was originally Tor originally stood for the onion router, and I'll explain that here in a minute, and it'll become a little bit more clear why it was called that. But now it's just called the Tor network. It can run any protocol through, that runs over TCP. So primarily think of things like your web browsing. The EFF, the Electronic Frontier Foundation, is a major sponsor and funder of the Tor network. But the important thing to know is that the Tor network isn't controlled by one entity. So there's a lot of different nodes within the Tor network, and we'll talk a little bit about it here in a minute. But there's a lot of different nodes in the Tor network, and some may be run by nonprofits. Some might be run by like universities. Some might be run by individuals, but there's not, nobody owns the Tor network. It's a open type of network. So basically, the way the Tor network works, and we'll show a diagram here in a second, is that the reason why it was called the onion router was because it's basically a layered approach to sending network traffic. So show here. Basically, on the left here, you have your Tor client, which is your browser. And now, to be clear, you're not using Firefox or Chrome or Edge, but you're using the Tor desktop browser. So it is built similar to Firefox, and we'll show an example, or we'll show a demo here in a minute. But basically, the Tor client is your browser entry into the Tor network. And if you're trying to get out to a site on the Tor network, which is your destination here on the left of this diagram, you're sending your packets basically to that entry guard, and then the entry guard sends it to the middle relay, and the middle relay sends it to the exit relay, and the exit relay sends it out to the destination. So that's your circuit, right? Those touch points that's going through. Now, the way the Tor network works is through what they call PKI, or public key infrastructure, and this is encryption using two different keys. So basically, the way this type of encryption works is that one key encrypts, one key decrypts. All right. The key that encrypts is used by the Tor client, and you basically work your way back when you're encrypting. So the Tor client's going to take the encryption key from the exit relay and encrypt the packet. Then it's going to take the encryption key from the middle relay and encrypt that packet. And then it's going to take the encryption key from the entry guard and encrypt that. I'm not going to get into details of the different keys and why that works. It's really called public and private keys, but just for sake of simplicity here, we'll just call them encryption keys. So because you encrypted in that way, you encrypted first at the exit relay, you encrypted then the middle relay, and then you encrypted the packet or the entry guard. You encrypted that packet, at each one of those levels. Only so in the case of the entry guard, it can only decrypt the portion of that packet that was encrypted by its other key. So as I mentioned before, there's two keys. There's an encryption and decryption. So you encrypted with one key, the entry guard decrypts with the other key, and only it has possession of that decryption key. So it's able to decrypt, and when it decrypts that, it looks at what it has, and there's no information about what's inside the packet. So it doesn't know the contents of the packet. It doesn't understand, like it doesn't know what you're sending to it. It doesn't even know where it came from. All it knows is it received the packet. It can decrypt it, so it decrypts it. The only bit of information that it has, and again, I'm trying to keep, I'm keeping it simple here, but the only information that it has at this point is to know where to send it next. So the entry guard gets that initial packet. It says, oh, I can decrypt this one part because I have the key to decrypt it. Once it decrypts it, it says, oh, I need to send it over to the middle relay. It has no idea what's inside of it, no idea where it came from. Middle relay gets it. It's the same thing. Decrypts its portion of it. Has no idea that it came from the entry guard. All it knows is it has to send it out to that exit relay. When the exit relay gets it, same thing. No idea where it came from. All it knows is it needs to send it to a destination because that's the only portion of it that it can encrypt or that it can decrypt. So that's really how the Tor network works, and that's why it's anonymous, because at no point does any of those points in the circuit know where that packet came from or know what the contents of that packet is. And when we say packet, I apologize, but when we say packet, it's just basically, the data and metadata that's associated with that data. Um, so at no point does any one of those relays or the destination know where that came from, and only the client and the destination are the only two that know what the actual content of that information is. So in a nutshell, that's how the Tor network works. So one thing to keep in mind here is that the dark web's not accessible, as I mentioned before, through your common browser. So you're not going to be able to get to these hidden services, what they call hidden services. You're not going to be able to get to them through, through IE or Chrome or Mozilla, Firefox. And these hidden services include things like search engines, Dropbox, messaging boards, currency exchange, e-commerce. So it's basically, they call it the dark web because it's basically a web, similar to what we're accustomed to when we go out surfing the web. And although there's other ways to access the dark web, Tor browser is the most common. And you will notice here, as we show an example, that in a minute, that the domains, the top level domain, we're all familiar with .com, .net, .org. This for the hidden services, it's going to be .onion. So that's how you know that it's a hidden service. So, these types of services aren't all for bad purposes. As I mentioned, there's a lot of different types of there's a lot of different services that are available in the Tor network. Things like communications, like Tor Mail or Tor Chat. You see whistleblowers using these services to, provide anonymity to them as they're, potentially uncovering things that could be damaging to people, companies, countries. So you see them using those services to make sure that they're protecting themselves. You're also seeing in repressive regimes, places like North Korea, China, places in the Middle East, where these services are being used, where then obviously the internet in those countries are far more locked down, and there's a lot less freedom on the internet. Journalists use it. So Edward Snowden was a big proponent of using the Tor network when he was having conversations with journalists to make sure that their communications were properly secured, and that nobody was able to eavesdrop or get information from those communications. Police also use it during sting operations. Unfortunately, on the dark web, you have a lot of bad actors and bad things that occur. So the police are obviously using these services, just like the bad guys are, setting up sting operations, getting and hopefully catching some bad people and some bad acts. And then, of course, the military uses it when they're in locations where they don't trust the network, which is pretty common especially for the U.S. military, where the U.S. military is pretty much all over the world. And there's a lot of times where they may not be able to trust the network that they're on. So they'll use the Tor network to exchange data to make sure that it's secured. So with that, we'll go through a Tor demo here. And so this is Kali Linux virtual machine that I have. And you'll see here the Tor desktop. So I'm going to go ahead and access the Tor network. Make sure it's working. There we go. So you see here, firing up the Tor browser. It looks very similar to Mozilla because it was built basically off of Mozilla. And I'm not connected anywhere, so there's no circuit that's been created yet. So I'm going to go ahead and go to DuckDuckGo, which is a search engine. It's a privacy-minded search engine. And we're going to try to go find some hidden services. Now, one of the easy ways to find these hidden services is go to Wiki, and you'll see here that the circuit was created and where the different endpoint or different nodes that it was going to. So one thing about the Tor network, it's not known for speed. So you're not going to be streaming videos through this, but you are, that's not what it's designed for. So here you'll see a list of hidden services, and this list is not obviously all encompassing. There's other ways to find hidden services. A lot of times they're not even published anywhere or publicized. You need to know somebody to know how to get to it. But you'll see all the different options here. We're going to take a look at social media, and yes, Facebook has an onion site. So as I mentioned before, there's the hidden services have a .onion top level domain. So instead of .com or .net or .org, you see the .onion, and you'll see the name doesn't look, it's not Facebook.com. Obviously, it's a little bit different than that. So I'm going to fire up Facebook, and again, you see here it's not very fast. And here we are at Facebook. So now what I do want to show is that you can then copy that domain or that URL. I'm going to go ahead and go into Firefox and show here that that Firefox is not able to get to that same, it's not able to resolve that same URL because it's not in a Tor browser. So I'm connected to Google, so there's nothing up my sleeve there, but when I connect or try to connect here, it's going to server not found. So, and again, this is something that the Tor browser is not difficult to install. Anybody, you don't need a Kali Linux machine to do this. You can download it on your Windows desktop or Mac or Linux desktop. It doesn't matter. It's not very difficult to install. Within a few minutes, you could be browsing privately on the Tor network. So here's what they call the dream market. So this is one of the marketplaces similar to, many people probably heard of Silk Road. This is very similar to that. It's a marketplace for selling goods and services. So as you'll notice there in the top left in the URL, there's a very there's a gibberish looking URL with the .onion, so we know we're on a hidden service here. And basically I'm going to go and try to take a look for medical records. And you can see all the different goods and services that you can buy there. A lot of drugs apparently. But I'm looking here for medical records, and we'll show just how quickly it, how easy it is to kind of locate, databases and information. So now, you can't always guarantee that this is medical records, but you can see here 3.3 million records, 700,000 records, 24,000, and so forth. The prices that you'll see there are in Bitcoin. So you do have to have a Bitcoin account and, and some way of, having a Bitcoin wallet and being able to make the purchase. Now, I will say that it's not as easy as Amazon, where you just click, buy now button. A lot of sellers that sell these things, obviously for good reason, don't always want to trust the person they're buying or they're selling to. So you do have to prove yourself before you can just make a purchase like that. As you notice here, I started looking for credit cards as well. You'll see that the prices, I should pay a little bit closer attention there, but the price is a lot lower than what it was for the databases. And some of these credit cards, obviously are in different states. As I mentioned before, you don't always know. You may have, some of these may not even have the right amount of information. So you see there one that says no addresses. So it depends. You may not be able to use them. You may not be able to. That you won't have all the information you need to make a purchase. So again, it depends on the information that's in here. But what I will say is that one, the UK one with the no addresses, you can see the price is a lot higher. Not a lot higher, but in some cases higher than some of the other ones that are just, gift cards or whatever else. So what can we do? From a business standpoint, as far as the people that are collecting this data, be prepared for more regulation. The GDPR, the California Consumer Protection Act. They're not going anywhere, and in fact, there's other countries and other states that are looking at very similar privacy rules and laws that they're trying to push. People, you could definitely see, and maybe it's me being in the security business, but you can definitely see the change in mindset where people, I think, are starting to get a little creeped out about the amount of data that's being collected and how that data is being used, especially when you're seeing the breaches all the time. So you are seeing a lot of people raising concerns about this, and you see governments reacting. So know your regulations and the governance and the policies that are, especially in your specific area. So obviously, financial companies are going to have different rules and regulations compared to healthcare or IoT or utility and so forth. Only collect the data that you need to operate. So know when you need, the high level data, project data. Maybe you're only looking at trend lines. You're only looking at, if you're only looking at trend lines, you don't need things like everybody's social security number. You only just need to know specific things about the trend that you're trying to track. And then also know when you need to collect that lower end data, that the more granular data. If you're trying to target specific users or specific customers, then obviously you may need some more granular detail around that person. And then make that data a strategic asset. So a lot of companies treat their hardware, their software, their people as strategic assets, in their physical locations and so forth. Data should really be no different. We're definitely seeing that data is becoming a commodity that's being bought and sold all over the place. So there is a lot of value that's that's associated with that data. So it should be considered a strategic asset, just like anything else. Have the ability to forget people. That's a very difficult one. And it's when you look at the internet and just the way that it works, we all know that just deleting something doesn't mean that it's gone off the internet. The internet is inherently redundant. So it's very, for those that stay up to date on technology and especially security, you may hear these stories of people that delete tweets or delete posts, but somebody took a screen capture or somebody shared it or something like that. So that stuff's never really gone. You can't. It's very difficult to have that quote unquote delete function. Now, I believe GDPR did put in that you have to have the ability to forget somebody. That's going to be difficult for companies to do. My opinion, I think, is that most companies are going to state that they were able to delete that person from their networks and from their data, but that doesn't account for where that information may have been replicated outside. So it's a very tricky one, but it is something that's definitely something that a lot of consumers are looking for. And then be transparent about the data that you're collecting. It's okay to collect data on people, but don't be a creep about it. There were studies that have been done that showed that people are more accepting and receptive of that data being collected if the company is more upfront about, hey, we're collecting this data. This is what we're doing for with that information. Just so the person is aware of it, and then also allow an option to opt out. So, if as a consumer or customer or client of that service, I should have the ability to say, no, thank you. I don't want you tracking me. I don't want you selling my data and so forth. One important thing to remember is that virus protection isn't enough. The days of being able to put a blinky box on the network to solve all the security problems, not that they ever existed, but that mentality is long gone. Know your systems, know where your critical data is. Spoke about that before. Make it a strategic asset. So knowing where that information is, knowing what protections you have around it, is critical. So knowing where that sensitive data is and having it separated from your non-sensitive data is key. And then only capture that sensitive data when necessary. Like I mentioned, that difference between the strategic level and the more granular tactical level. You don't need to store social security numbers if all you're trying to do is get trend lines. Practice least privilege and need to know. This just basically means that not everybody needs to have access to sensitive data. when I was first getting into the security field and going through training and education. One of the things I think that clicked with me is that, and this seems obviously now, but that the CEO doesn't need read access to a sensitive database. It's like, well, yeah, of course not, but he's the CEO, or he or she is the CEO. But that doesn't make it that doesn't mean that person needs to have access to sensitive information. So it's on a need to know basis, regardless of what your level is. It's just something, I think, a different mindset where always provide least privilege where applicable. Log access to data, especially critical or sensitive data, and make sure that people are actually looking at those logs, or that those logs are being ingested by some service, whether it's Splunk or a SIM or something like that, that's able to correlate that information, send out alerts, and so forth. Raise your security IQ through security awareness training. Everybody is responsible for security. A lot of security people love saying that. And security awareness training is cheap. It can be effective. And I think it's important to treat security awareness training as good just security hygiene. And it doesn't mean that just your engineers need security training. The people that are working the front desk need it just as much as your executives need it. So again, it's cheap, and it can be effective if done properly. As far as ransomware goes, one of the easiest ways to protect yourself against that is, having a data backup, and more importantly, having a recovery plan. So what we've seen in the security space is that a lot of ransomware attacks that occur, the victims of those attacks will sometimes pay the ransom because it's cheaper than trying to restore from backup. So having backups is great, but being able to actually restore from those backups in a cost-effective way, and in a way that creates little disruption to your business, is more critical than creating those backups in the first place. Ransomware is definitely not going away. It's crippling a lot of businesses, and it can be crippling to some businesses. Have it sounds boring, but have a robust patch management program. This is like brushing your teeth, right? Patch management is the unsung hero in security, right? It's the one thing that doesn't get a whole lot of fanfare, but if anything, it's probably the most important thing as far as security goes. Knowing where your system, knowing what systems are running what level of software, and being able to push out a patch to those systems and software, within a short period of time, preferably in less than 24 hours time, will save a lot of headaches. Because a lot of times you'll see once a CVE comes out, like a known or a vulnerability that becomes aware to everybody, you'll start seeing that show up in the wild pretty quickly afterwards. So, if you don't have the ability to push a patch, because a lot of times when those vulnerabilities are come out, the first, if it's a Microsoft vulnerability, Microsoft's going to, create a patch and push it out and say, okay, here it is. Well, it's up to the company to be able to push that out to all their Windows machines. So you'll see Microsoft turn that around pretty quickly, but some of the companies aren't always able to do that. And I'm not picking on Microsoft there. And the last part, especially around data, is encryption. Encrypt at rest, in use, and in transit. So when we talk about at rest, that means when the data is sitting in a database or on a disk somewhere. In use means when it's being processed in memory. And then in transit, of course, is when it's actually going across the wire through a network. You want to make sure that data is encrypted at all three of those stages. And you don't have to encrypt everything, but because there are a lot of trade-offs with encryption. Systems are becoming much more fast these days, so the latency issues or concerns from years going by, I think those have been. They're less of a concern these days, but there is still some concerns around supportability of encryption. If data is encrypted, it's hard to support it's hard to support software if you can't see the data, if it's encrypted, and so forth. So You don't have to encrypt everything, but most certainly your sensitive data should be encrypted at every possible stage. And with that, I thank you for your time and appreciate you taking some time to listen to this talk. I hope you enjoyed it, and please feel free to reach out to me, and thank you.